So, hello everyone. So, my name is Luigi A. Samole. So, I'm the fifth reporter. So, my topic is all about flow in closed conduit, design of water. So, first, energy. So, what is energy? In general, the word energy refers to a concept that can be paraphrased as the potential for causing changes. And therefore, one can say that energy is the cause of any change. Energy has ability to do work. So energy, so sa to siguro tanan kablo na ta. So what is energy? So next is Bernoulli's energy theorem. So in my topic, uh, I will discuss to you what is Bernoulli's theorem, derivation, and what is the sum of formulas na magamit na to for determining energies like kinetic or potential. So the first is Bernoulli's energy theorem. So the theorem states in effect that total mechanical energy of the following fluid comprising the energy associated with fluid pressure, the gravitational potential energy of elevation, and kinetic energy of the fluid motion remains constant. So in Bernoulli's theorem, so there are some equations here na makakuha ka og potential energy and kinetic energy. So let's proceed. So first is Daniel Bernoulli. So who is Daniel Bernoulli? So Swiss mathematician and physicist and was of the many prominent mathematicians in the Bernoulli family from Basel. He is particularly remembered for his applications of mathematics to mechanics, especially fluid mechanics. So, sa tuwa siguro diri no, kabalo naman siguro ta kung ay kanang familiar na sa tuang fluid mechanics, ang sa to man na anong ban siguro naga-take pa or wala ko kabalo. Then let's proceed. So Daniel Bernoulli. So he was born on February 8, 1700s in Groningen, Netherlands. So he died March 17, 1782, Basel, Switzerland. So he was 82 years old at that time. So oh, next is mao ni si Daniel Bernoulli. So next is Bernoulli's theorem derivation. So Bernoulli's theorem equation. So as you can see here sa akong illustration, so at the left side, this is the pipe. This is the pipe at the left side and this is the pipe at the right side. So first it at the left side, so A1 is the cross-sectional area and X is the distance of this pipe, this pipe distance. Then P1 is the pressure, H1 is the height, V1 is the volume, and this one V1 is the velocity. Same as the right side, we have H2, volume 2, pressure 2, cross-sectional area 2, velocity 2, and the distance. So in determining to come up this formula right here, the final equation, so we have some concepts to get this equation, the final equation. So first is this dv over dt1 equals dv over dt2. So this is the time change constant equation. So here, these concepts, we can relate this to come up this final equation. So first is this. So dv equals dt1 equals dv over dt2. So we know that v, volume, is cross-sectional area or area times the distance x. So d times area 1 times x1 over dt. Same as at the right side here, cross-sectional area times distance. So d times a2 times x2 over dt. So next is the derivative. So area 1 times dx1 over dt equals a2 times dx2 over dt. So as we can see, the definition of this dx1 over dt is the velocity. So velocity here. So V1. So we can simplify this concept or this equation as A1 times velocity 1 equals A2 times velocity 2. So that is the first concept or the first equation that we can get. So next is we have here the W equals FD. So work equals force times distance. Work equals force times distance. So as you can see here in my illustration, so work. So the left side will be the work 1 and the right side will be the work 2. So first, so as you can see, so work 1 has the biggest area cross-sectional and the right side is have the smaller. So first is we can we can we can generally equate this as W1 equals P. What is the force of pressure 1 times the area times distance. So W1 equals P1 A1 times X1. Same sa right side na W2 equals P2 A2 X2. So we can come up with this equation. So the next part is work 1 minus work 2. So based sa akong research or sa mga reviews, work 1 has the larger area than the area 2. So we can I assume that this will be so mo ni ang pinakadako og para ma-determine nato kung ang iyang kung unsay difference sa iyang kinetic energy and potential energy. So W1 minus W2 equals the change of potential energy plus the change of kinetic energy. So next is W1 minus W2 equals M2 GH2 minus M1 GH1. So from my research and reviews, so M2 GH2 is the final potential energy and M1 GH1 is the initial. So when pagdako ang M2 GH1 kaysa sa M1 GH1, so the result will be positive. So we gain energy, we gain potential energy. And if mas gamay ang M2 GH2 kaysa sa M1 GH1, so negative ang result, so loss ang potential energy. So let's continue. Plus 1 half M2 velocity 2 squared minus 1 half M1 velocity 1 squared. So this is the kinetic energy, the potential energy. So we know that W1 work is force times distance. So force times distance is pwede po na ito mapuan siya as this one. Pressure is equals to force over area or F equals PA. So in this situation, so kabalo na ta nga mo ni work is force times distance. So P1 times area 1 times distance x1 minus P2 area 2 x2 equals the potential energy. So M is the so this is the density. So density equals mass times mass over volume or mass equals density times volume. So para nato siya ilista lang nato siya para makasimplify ta. So mao ni ang result. So P1 A1 X1 minus P2 A2 X2 equals to rho V2 GH2 minus rho V1 GH1 plus 1 half. Same lang gyapon diri sa kinetic energy. Ilisan gyapon nimo siya. Plus 1 half rho V2 times velocity 2 squared minus 1 half rho V1 times velocity 1 squared. Excuse me. So next is P1 A1 X1 minus P2 A2 X2 equals to rho. So V we can know na V is equals to volume, area times distance. So, lista na po na to siya to equate or to para makakuha tani nga formula. So, rho, ilista na to ang V, ang volume sa A2, A2 area, A2x2 times GH2 minus rho, area 1, x1, GH1 plus 1 half rho, same yapon dire sa kinetic energy, A2, x2, velocity 2 squared minus 1 half rho, area 1, x1, velocity 1 squared. So, mao na ang atong na-come up na equation. So, next is atong ibalhin ang mga pareha ni ang mga kauban ni area 1 o ni area 2. So, left side transfer lang. So we come up P1 A1 X1 plus rho A1 X1 GH. Excuse me. Plus 1 half rho A1 X1 times volume velocity 1 squared equals P2 A2 X2 plus rho A2 X2 GH2 plus 1 half rho A2 X2 velocity 2 squared. So, kabalo man ta nga naman sila yung mga kapareha. So, pwede na to ni ma-simplify. So, we know V1 equals V2. So, V1 is area times distance. So, just divide both sides by A1 x1 and A2 x2. So, we can simplify the final equation to pressure 1 plus rho GH1 plus 1 half rho V1 squared equals pressure 2 plus rho GH2 plus 1 half rho velocity ay volume V2 squared. So, mao na ni ang final equation ni Bernoulli's theorem. So, next. So, example. So, water flows through a horizontal pipe with a cross-sectional area of of 4 meters squared at speed of 5 meters per second with a pressure of 300,000 PA at point A. At point B, cross-sectional area is 2 meters squared. So A, what is the speed of the water at point B? And B, calculate the pressure at point B. So, this is my illustration. So, the drawing. So, as you can see, wala siyang height. Walay height. So, meaning naala siya sa surface or sa land. So, A. So, the pressure A is 5 given. Nasa problem. So, 5 meters per second. And atong kuhaon ang pressure B. So, area 1 is equals to 4 meters squared and area 2 is equals to 2 meters squared. So, we can come up with this formula. V1 equals V2 or area 1 times V1 equals area 2 times V2. So, 4, so that substitute 4 times 5 equals 2 times V2. So, the final answer is V2 is equals to 10 meters per second. Next is the letter B. So, this is the Bernoulli's theorem equation. So, as you can see, walang height. So, nasa surface lang. So, P1 plus PGH1 plus 1 half PV1 squared equals P2 plus PGH squared plus 1 half PV2 squared. So, wala siyang height. So, cancel out to come up this final equation. Pressure 1 plus 1 half PV1 squared equals pressure 2 plus 1 half PV squared. So, substitute 300,000 plus 1 half times 1,000 times 5 squared equals P2 plus 1 half times 1,000 times 10 squared. So, 312,500 equals P2 plus 50,000. So we can come up this final answer, P2 equals 262,500 pascals. So next is the head loss in pipes. So refers to the measurement of energy dissipated in a system due to friction. It accounts for the total energy losses due to the length of a pipe and those due to the functioning of fittings, valves, and other system structures. So head loss sa pipe. So if naa siya height, head loss, so tanaw na nato kung ang saan difference sa iyang height. So head loss. So next is, there are three methods in determining head loss in pipe. So first is the Darcy-Weisbach. Next is the Manning's formula. And the last one is the Hazen-Williams formula. First is the Darcy-Weisbach. So the formula is HF equals 0.0826 F LQ squared over D raised to 5. So, ang kaninga mga formula, nani sa to ang hydraulics. So, where F is equals to friction factor, L equals to length of pipe, Q equals to flow rate, and D equals to the diameter of pipe. So, next is the Manning's formula. So, V equals 1 over N R raised to 2/3 times S raised to 1/2. HF equals 6.35 N squared L V squared over D raised to 4/3. Next is HF equals 10.29 N squared L Q squared over D raised to 16 over 3, where N is roughness coefficient, R is hydraulic radius, S is slope of energy grade line. Last is the Hazen-Williams formula. So V equals 0.8492 C R raised to 0.63 times S raised to 0.54. Q equals 0.2785 C times D raised to 2.63 S 0.54. HF equals to 10.64 LQ 1.85 over C times 1.85 I raised to 1.85 times D raised to 4.87, where C equals Hazen-Williams coefficient, R is the hydraulic radius, S is equals to slope of energy grade line equals HF or over L. So example, so new cast iron CHW equals to 130, N is equals to 0.011, has a length of 6 kilometers, diameter equals 30 centimeter, Q equals 0.32 m cube over S, T equals to 30 degrees. Calculate the head loss due to friction using Hazen, Williams, and Manning. So these three methods determining the head loss in pipes. So magamit mo ni siya depende sa mga given or sa mga what you call that, kanang mga data, given data sa mga papuan na problems. So my example is this. So Hazen, William, and Manning. So so the formula is HF equals 10.7 times L over CHW1 raised to 1.852 times D raised to 4.87 times Q raised to 1.852. So direct substitute only, we can come up HF equals to 10.7 times the 6,000, 6 times 1,000 over 130 raised to 1.852 times 0.3 raised to 4.87. So we can come up 0.32, 1.852 equals, the final answer is 333 meters. So Hazen-Williams method. So next is the Manning method. So HF is equals to 10.3 L over NQ squared over D raised to 5.33. So direct substitute, HF equals to 10.3 times 6,000 times 0.011 times 0.32 squared over 0.3 raised to 5.33. And the final answer is 470 meters. So that's all. Thank you. Keep safe and God bless everyone.